Okay, thanks for the introduction. So this is joint work with Rasmus and Patrick. So this is follow-up work similar to David's talk from last year's paper where we presented a goal importance metrics. Now, why do we look at this? Well, not all goals are of equal importance or have the same impact and outcome of a game. So I think many of us have at least heard of this goal. So depicted here by Bobby Orr scoring the Stanley Cup winner in 1970. So many of us have probably dreamt of scoring that goal and realized that, well, that's a pretty important hockey goal. Some of us are Swedes, so we remember this goal from '94 when Peter Forsberg won the Olympic gold for us on Corey Hirsch. Some of us are Canadian. Some of us are both Swedish and Canadian, so we can celebrate both of these goals. So this is the infamous golden goal where Sidney Crosby won the Olympic gold for Canada in the final game of the Olympics, the final event, huge sort of celebration all over the nation. And in more recent times, we have in each Stanley Cup playoffs, we have somebody that steps up and score those big goals here, personified by Matthew Tkachuk winning or more or less winning game 4 against the Hurricanes with 5 seconds left of the game. So what is it that make these goals special? Well, and more importantly, how do we measure importance? Let's consider first a regular goal. So we have 2 different goals. We have a scenario A, where essentially a home team is trailing by 1 and then tie the game. Okay, so that's scenario A, late in the game, 54 seconds left. The second goal, they're up by 6-1 and score a 7-1 goal. How many here would consider it's equal value? Probably not. Yet when we count points, that's what we do. We give them equal number of points. So how many would think scenario A should be awarded more points? It's more important. And so essentially what we were interested in, well, can we sort of quantify that? Can we derive sort of a metric? And essentially that's what we then presented in LINHAC last year, which to be honest was sort of an extension of some early work we did one year earlier. Now, what is the basic idea here? Well, we have this game point importance value that essentially look at what is the change in expected outcome of this game due to this goal. So we can say we can measure it in terms of the teams get some points, okay? And it's more likely we're gonna win this game if this goal is scored than the likelihood of us getting these points before scoring this goal. Now, can we tie this to the 4 goals that we've seen? Well, instead of team points, let's consider national happiness. Well, before, well, we were on the edge, right? And then we scored the goal and we're enormously happy. So why do we remember these goals? They're of high importance. They score extremely, extremely high here. And what we want to do is we want to do the same thing with regular goals, okay? So essentially then we develop this thing, and what does it take into account? Well, the context before the goal and the context after the goal, okay? But that context can be quite complicated, so we keep track of a whole bunch of state. And this might make it hard to interpret. So I assign each goal a value, but what insights do I get out of it? Yes, this goal have high importance, this is low. How do I explain it to somebody? And that's what we then try to do in this paper. We try to make simpler, easy to use variations of these GPIV measures. So essentially, we still want to assign each goal a value based on, but on a smaller sort of set of states. And what we're going to do is we're going to motivate the choices that we make with the help of decision trees, so a type of machine learning. And then sort of looking at the importance of different parameters, okay? And based on this, we're going to define some approximation and then provide insights into that. These metrics have some desirable properties. So they capture the most important aspects of this KPI-V metric. They're easy to apply, they're relatively stable, and they're more intuitive. So we can look at things and we can interpret the results all of a sudden. And we hope that this now provides practitioners an easier and straightforward way of applying these type of metrics. Of course, with whatever tweaks that each team or each newspaper or news station might see suitable for their case. So if we go back to this one, so this is sort of the high level ID that can be translated into sort of probabilities instead, where we essentially now at a high level, we're looking at NHL data. So in NHL, you get 2 points for a win, you get 1 for an overtime loss, and there's always somebody winning the game. So it's either 0, 1, or 2 points. So when do I get 2? Well, that's when I win. So essentially, the value of a goal is the increased probability of essentially winning a game that I give a weight to. And then plus, well, with weight 1 for sort of a tie. So how much do I increase the probability of a tie? So that's the basic idea. Now, let's go and have a little bit of deeper look and build some intuition for each of these terms. Many of you have seen these type of graphs where it's sort of it's the probability over time of a team winning a game. So here it's the Flyers versus the Stars. And so I mean here they say, well, okay, the home team has some advantage, so it's more likely. In our model, we don't take that into account. It started at 50%. But you can incorporate that if you want. But when you score a goal, here you see a big change. And we quantify this. That's essentially the value that we put in this change. And that's for winning the game, okay? You can do the same thing for tying the game. So now you do a similar curve for tying the game, and then you pick out those delta values. So that's essentially the idea. Now we can translate these ones into probabilities, and we just have this background information, and we get a model, and you can train this, etc. We just use basic statistics. So we kept track of the statistic from a season, and we got values, and then those are the ones that we then interpret. Okay. Again, the problem here is that we have a very fine-grained state space. So what we wanted to do was to, so this state space that we had last year was the goal differential, the manpower differential, and the time in seconds. So very fine-grained. You could even include more. But okay, which are the most important metrics? So what we did was we created a decision tree, and we calculated how much of the variance were explained by each of these parameters. So now if we take the red things here, are essentially splits points in this decision trees where the goal differential was the deciding factor in this model. And we can see that that's the most common decision point. What is the goal differential? And in terms of variable importance, it has a much higher value than the other ones. So that's going to be our most important variable. The second most important variable is going to be the one with the second most splits, and it's going to be the time of the game. And these times are in seconds. You see that they're all high values. It essentially means that the splitting points are somewhere in the third period. So is it in the end of the game or is it early in the game? And similar to before, the blue, it has sort of explained a fair bit. The least important thing is just the manpower differential. Do I score in power play or do I score 5-on-5? Doesn't seem to matter that much. The important thing is that I score. Okay. So what we decided was, well, create 2 models. one where we only look at the goal differential, or most important one, and one where we use goal differential and time. So the first metric, we look at goal differential only. So, and we broke things down even further. It's not -5 to +5. Instead, what we saw that was, well, it's mostly, do I reduce the deficit, or do I tie the game, or do I take the lead, do I extend the lead, or do I score an overtime winner? Which of these metrics do you, or which of these ones do you think should have the highest goal value? How many think overtime goals? Okay. How many think that it's reducing the deficit? Tying the game? Okay, so we have some tying the game. Taking the lead? Some. Expanding the lead? So we have different opinions. So I'll give you the answer. Tying the game. So I'm going to explain later and give an intuition for it. But to an extent, an overtime winner in NHL, it's sort of, okay, you either get sort of 1 point or 2 points. So you just add on average 0.5. Okay. Now, with tying the game, consider tying a game late in the game. Okay, so now I go from not getting any point to likely 1 and possibly 2, which then is of higher value. Okay. Extending the lead, not too useful in most cases, because here you get this volume of goals that are sort of just padding the lead. So a lot of goals in that category. And here we also see sort of a breakdown in terms of how many goals are there in each category. And we can see that, well, tying the game, there's not a whole lot of them. Teams are fairly defensive oriented. When they lead, it's hard to make goals. So scoring those goals are going to be of high value. Okay. So here we looked at goal differential only. Let's split it into period. Get a little bit more intuition. So if we start with the tying the game, we can see that in the first period, it's definitely less than what we saw with the overtime. So the overtime was 0.5. And it's not until in the third period where we actually outperform the overtime winners. But at that particular point, yes, tying the game late, that should be a big reward to that player and to the team, where it has big importance for the outcome. Okay, taking the lead, we can see that it also increased over time, so more and more important, but not as important as the overtime winner. And extending the lead becomes less and less important the later in the game it is. So a little bit of an intuition there. And so to some extent, it's sort of the differences grow over time. Now, so what's useful with these metrics? Well, over time, over different seasons. So here, I guess we have a season, 2007, 2008, and so forth, up to 2013, 2014. The metrics have been fairly stable. So the weights have been fairly stable and sort of a strict ordering. So it's not that we looked at a particular season and we saw something there. It's true over time. When we break things down into sort of these both dimensions, so we have both periods and we have what type of goal it is, we see a little bit more variability, but it's still a relatively strict order, especially in terms of importance in the third period. Okay. Another nice property of this metric is that it is highly correlated with both the traditional metrics in terms of plus minus, goals, assists, etc. We argue that the GPI V value is more useful than the traditional one. And what we can see is that this simpler metric actually has higher correlation with the GPI V rather than with the traditional metrics. And this is true for both the goals, assist, the points, and the plus minus. So it captures sort of the important aspects of it. We've also seen sort of in terms of there's sort of a gradual decrease. The more information we take, the farther it is in terms of correlation with the traditional metrics. So when we do GD only, we have relatively high correlation with the traditional, and with the full, we get a little bit less, but still high correlation. And similarly, we can compare everything to the GPIV. The traditional have the low, but then the more we add in terms of 1 dimension, 2 dimension, the higher correlation we have with this GPIV value that actually calculate the true importance value of each individual goal. So by just taking the average for different groups, we can actually get a pretty nice proxy. If you look at player ranking at the particular season, I think this was the 13-14 season, we can see some names that with the GPIV have increased in rankings. With point rankings, they were ranked 8 to 11, these two players, Ovechkin and Bäckström, and they now got position 2 and 3 if we took sort of goal importance value into account. Looking closer at things, well, one of the reasons was that Ovechkin scored an awful lot of game tying and lead taking goals that season. And then when we go to sort of the water down into only taking 2 dimensions into account, they don't get the same extent when we only do the GD. They don't get the same benefits, but they still do jump in the ranking in the right direction. When we look at sort of a larger set of players, so here we have the top 15, we can see that especially for the top players, it doesn't matter too much. They score a lot of goals, a lot of points, but we see bigger variations for the players sort of below that in terms of jump in ranking depending on how we measure things. And then as perhaps expected, with the plus minus, we see the biggest uncertainty. So we see big variations in the rankings of plus minus compared to with goals, etc. So to conclude, our contribution is essentially 2 simple metrics that are variations of this GPIV metrics, where we assign each goal a weight based on sort of a smaller set of states, and we motivate these in terms of using this tree-based approach and looking at the importance of each variable. And we define then based on that these approximate metrics that are nice in that they capture the most important aspects of the GPIV. They're easy to apply, they're relatively stable, and we get these intuitions about which goals are actually important. So we can reason about these things. And they hopefully then provide practitioner an easy and straightforward way of creating their own metrics that take these into account. So essentially, you can take exactly what we have, or you can build more things into your GPIV metrics, but that just take into account the state before and after a goal. And with that, I think I conclude the talk. Questions? Yeah, David.
Hey, thanks for the talk. So the one slide you had with Ovi and Backstrom, and you said Ovi scored many goals assisted by Backstrom. Were there assist values too handed out?
Yes.
Okay. What can you elaborate on those? Like I'm assuming the GPIV value goes to the goal scorer instead of just a +1.
So essentially what we did was that for the goals, then it's the GPIV value to the person scoring the goal. And for assist, we took the GPIV value for the person doing the assist. And for plus minus, we took the GPIV value if it was a plus, or the GPIV value if it was a minus. So okay. If you let in an important goal, then you got a bigger minus than if you let in sort of a who cares goal.
Okay. So the assists, they would get the GPIV value as an assist.
Yeah.
Okay. Okay, cool. Thanks.
detailed times? Like I'm guessing at some point in the third period, things change a little bit.
Yeah.
Did you look at that at all? Like to see at what point does the takeover become more important than the time?
Yeah, so I mean, to some extent, we learned some of that from the decision tree in terms of, yeah, so I mean, now it was shown in seconds, but you can translate it into actual time. So that's one way we've looked at it. And another is that we plotted heat maps over the, and those are included in the in last year's paper.
Okay.
Yeah. So there you can see sort of on a, I can't remember if it's sort of minute per minute basis where the GPIV value actually spikes. Yeah. Any other questions? Yeah.
I'm going to ask you the same question you asked me. So you showed totals, season totals. Did you look at the game-to-game variation? I'm assuming it's similar to the point game-to-game variation.
Yeah, so we had Rasmus looking at the shorter time intervals as well. And I think he can be better at explaining what was going on there. But I think that to some extent the metrics are stable and can be used to sort of predict sort of the future. But I mean, as you sort of hinted at, when we look at goals, there's few goals being scored, so you have much more noise than if you look at passing metrics where you get a bigger volume, for example. So I mean, I would be cautious going down to goal metrics on too short of a time scale. And I think that's the really nice thing with like your work, where you look at passing metrics and you sort of capture things that are measurable at shorter time scales.
Yes, so we look both at stability over different seasons, but then also stability within a season. So we partition the season into 2, 3, 4, 5 to 10 parts. And the predictability, so if you have half of the season, it's easier to predict what the end result will be in the new kind of points or goals than if you only have 1/10 of the season. But we also found that the predictability was actually better than the traditional metrics. So our kind of goals or our kind of assists were easier to predict than the traditional goals or assists.
Yeah.
Please go ahead. You showed one picture where it was harder to tie a game. Do you think it would matter because the game starts at tied, so of course it would be fewer.
Yeah.
If you would exclude the first game in the goal, do you think that would affect the model in some way?
I don't think it would expect the importance of the goals, but I mean it would change the frequency with which we sort of how we interpret the frequency. So I think in terms of the assignment of the weights to them, I would sort of say, well, that's give a good interpretation, but the frequency is skewed because of the reason you say. Yes.
Yep.
So that's a good point. Other questions? Yeah.
You've been out there, but have you thought about? I haven't thought this through, but is there some way to figure out the importance of the first goal using similar techniques? A lot of times they say, oh, the first goal is going to be really important in this game.
Yes, I think the same approach would work there. So I mean, you take all the data and you put in the state space that you're interested in and do exactly the same thing. Yes. But with the state space that we have, the only thing that you would see there is that the later that first goal comes, the more important it is. Yeah. So the game stands in balance for a long time, and eventually somebody scores, and that's more important than goal in the first minute. Other questions? Yeah.
Did you look at the Swedish system with 3 points? I mean, you can still use the NHL data, but just try to mix with 1 point, 2 point, 3 points. If the taking the lead will increase more the chances of getting points because it's
I get-
1 and 2 points are pretty close to each other compared to 3 points when you take the lead.
Yeah, I cannot defer the question to Patrick. Have we looked at that?
We're waiting for some good data.
Oh, okay. Yeah. So we're hoping to get data supposedly. Yeah. But so I think we're hoping to get SHL data so that we can actually do it on leaf data. Good. Okay. Yeah.
Let's think,